Hello everyone, I'm Shanaz Malik and you're watching Data Analytics Professionals, and let's quickly jump into today's lecture topic. Now, as you can see from your screens and the lecture topic on today's lecture is about advanced imputation technique, and that's mice. And let's go and talk about this. And before we proceed, that please remember this is lecture number 36 in this series, and there are other lectures in this series. Now, the fancy impute package offers us various robust machine learning models for imputing missing values, and one of it is KNN, which we have already discussed and learned in the previous lecture. Here we will use iterative imputer, which is popularly called as mice, and which also stands for multiple imputation by chain equations. So we will use iterative imputer, which is popularly called, as I said, popularly called as mice, for imputing missing values. Now, the iterative imputer performs multiple regressions on random samples of the data and aggregates for the imputing the missing values. We will again use the diabetes data frame for performing this imputation. Now, please note, iterative imputer started its life as a fancy impute original, but was then migrated into scikit-learn, and this was done in favor of a better tested sklearn version. As a convenience, you can still use it from fancy impute and import your iterative imputer, but under the hood it's just doing the same and fetching everything from scikit.impute. Okay, that means if you update scikit-learn in the future, you may also change the behavior of iterative imputer, and just keep this in mind, so that if you are on the live projects or working for some organization, you have to keep this in mind. Okay, now let's move. Mice is a multiple imputation method used to replace missing data values in a data set under certain assumptions about the data missingness mechanism. For example, the data are missing at random. That's one of the assumption, and or the data are missing completely at random. So we will discuss the mechanism of mice at the backend process at some time in future, but at this moment of time, let's concentrate on the task in our hand. And for that, to see how how to perform imputation through mice, let's open our Jupyter notebook and learn by performing the tasks in our hand. And therefore, let's jump into our Jupyter notebook. So here I am in my Jupyter notebook now already. Now remember that you can create this Jupyter notebook or download Jupyter notebook this Jupyter notebook from my GitHub, and do it within the AWS, but then you have to bear in mind that you might face some charges, and you have to be accountable for that. But I, as a suggestion, always say to students and learning my peers, we can do same things outside the AWS. If you are learning and if you are trying to check how things are working, you can download Anaconda and do same thing on your personal machine, and it's up to you. Both ways, you will learn. And once we will learn, for example, I'm doing it outside AWS, because same thing can be done in AWS, as I have already shown in some of my previous lectures, that you can create notebooks in Jupyter notebooks in AWS and then work on it. But at the moment I'm doing it outside, as I said, in Anaconda, and then later when we take big projects, I will show you how to do those projects within AWS. So for complete package, you have to watch my all series, but let's concentrate on here. So here I'm just saying that we are discussing advanced imputation strategy mice. You can download this notebook from my GitHub account, which is here, and I'm not going to repeat all these line 1, line 2 until I think I actually impute fancy impute, I actually use fancy impute, because everything what I have done here from line 1 to line 2 and until I will tell you where, it is all discussed in a previous lecture, which is lecture number 35. And on in lecture number 35 we discussed all this. That is exactly same, and we discussed it for KNN imputation, advanced imputation technique. So I'm not going to repeat. If you want to know what I have done here, for example, I'm using Numpy pandas, and using them pandas to impute to create a data frame from my diabetes with missing values CSV, and then taking some samples and doing some using info function just to see what type of data types I have and how much missingness I have within the data, healthy, which data sets are healthy, sorry, which features are healthy and which are not, and taking some statistics using describe function in line A6. See, I'm not going to repeat this. I'm going to quickly go through it, then checking the nullity of the data frame and storing it in the df underscore nullity data frame. And by now you should be aware of all these. Then checking the head, taking some 10 top observations, and here I'm in line 9 calculating the total of the missing values, and now I can see in each feature how much missingness is there, and even I can also calculate the percentage. It is very helpful when you have large data sets and have millions of rows, and then these numbers doesn't make as much as they might make sense, but it's always good to see the percentage of missingness. And then visualizing using through missing no, I love this package. So and using missing no with the pyplot from matplotlib to actually create some beautiful visualization. And from missing no I use bar and pass through the data frame where there is missingness, and give some other arguments and their values, and then see these beautiful visualizations. And I also have used matrix from missing no to generate another visualization, and it actually helps us to see where is the missingness and how much is the missingness. And if you see, there are really nice ways to actually see the missingness. Okay, now again I am sorting my data frame using diastolic, and then those sorted values I am passing through the matrix, and then it again shows if the missingness is here, what is happening with the other features. And now the correlation between the missing data, you should remember we could find a correlation between missing data, and it helps us to gain a deeper understanding of the type of missingness. It also provides suitable ways in which the missing values can be addressed. So I'm not going to repeat all this. Okay, so here I'm using mat heat map from missing no and passing the data frame, and here I am finding that I have a strong correlation between triceps and insulin, which is 0.7, and it's in the positive direction. And this color bar, it tells you, the color tells you how strong is the relationship, correlationship between the two. So anything from towards redness and means the negative correlation, well as towards blue and towards the pinkish shows us that it is a positive correlation. So bluish is a positive correlation, and 0.7 is very good correlation. Now is a good correlation. And now again same thing could be seen from dendrogram, and I'm using dendrogram of missing no. And then if you see again, the triceps and the insulin is closely related, and as they are in a closed group. And okay, now here is the meat of this lecture. Okay, this is what I am was talking, that this is the meat. So from fancy import iterative imputer. Okay, so first thing first is this is the main thing. Until line 17 it was all done in the previous lecture, and trust me that if you watch my previous lecture you could have skipped until now. So line number 18. So from fancy impute we impute iterative imputer, and then I also copy my data frame using deep is equal to true, and I create a copy and store it into diabetes underscore minus underscore mice underscore imputed. Then I initialize iterative imputer and store it in a variable known as mice underscore imputer. And once I have the instance of this, and then I use my fit underscore transform method, and pass the data frame, where I have missing values. And I bring whatever is what the imputations are, and the result set is all stored in diabetes underscore mice underscore imputed, and I'm using iloc to go through all features and all observations and all features. Then there's a warning, it is a future warning, so ignore this at this point of time. We can discuss warnings about in separate lecture, where we can discuss only about warnings, but here we concentrate on then we take this imputed data frame now, and we check is there any null. Okay, we create and we store that in data frame called df underscore nullity. Now this is just to create a nullity data frame. Okay, and from our it's my mistake, it's mice here. Okay, so once we create this nullity data frame, and then we print the sum of this. So once we print the sum, we give the sum function to it and then print it, and we find there are no missing values. Everything is gone now. Okay, everything is gone. Everything was imputed. So if you remember, line number 20 shows all zero, and there was in the top somewhere, let's see where it was. Here it is in line number 9. When we executed this, we had some missingness here. Okay, but that all is dealt now using the beautiful and a very robust iterative imputer. Okay, and that is the way how it is done. And if if everything is if you like it, then I'm happy. And that's all from my end, for at least in this lecture. If you have any questions, please comment, and I will take them and do my best to reply to each question as quickly as I could. And in the meanwhile, I have a humble request, and that is, please support us by sharing this video and press the like button if you like this video. Your valuable comments and constructive feedback helps us to improve. And please subscribe, connect to my account if you haven't done until now, and please hit the notification bells so that you all get notified as soon as I upload new videos. And with that, I have to say, I hope to see all of you in next video. Until then, I thank you all for watching Data Analytics Professionals.